What is going on, everyone? Welcome to day 15. A minute and a half left, so we're just hanging out. Got our template ready to go back here. We are all compiled, got all our imports. Just chilling, man. Like, who knew 90 seconds is how to make yourself feel really comfortable? So we will see. We'll see what they have in store for us today. Should a little bit. I think you can basically see everything. Sec. Yeah, you can see here. All right. Cool. Just waiting. It's kind of interesting to go through yesterday's puzzle and just kind of update some stuff. You know, once you know how to do it, it's wild how easy these things are. Honestly, it sounds stupid, but definitely true. Just having like a little bit of context, kind of hard to go into a puzzle and not know anything about it. So, see though, we got all 28 stars so far. You see them over there. All those, and yeah, 9 seconds left here. So let's 4, 3, 2, and 1. We'll hit compile. We'll pick this up, do a bunch of sensors and some coordinates. Okay, so you feel a ground rumble. You have a large network of subterranean tunnels. You don't have to search them all, but you don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that you imagine were originally built to locate lost elves. Sensors aren't very powerful, but that's okay. Your handheld device indicates they're close enough to the source distress signal to use them. You pull emergency sensor system out of your pack, hit the big button on top, and the sensors zoom off down the tunnels. One sensor finds a spot it thinks will give you a good reading. It attaches itself to the hard surface and begins monitoring for the nearest source signal beacon. Sensors and beacons always exist at integer coordinates. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock onto the one beacon closest to the sensor. So let's read that again. It says, once a sensor finds it, attaches itself to the nearest source beacons. Sensors and beacons always are at integers. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock onto one beacon closest sensor and measured by the Manhattan distance. Haha. There's never a tie between a tie where two beacons are the same distance. Okay, it doesn't take long for the sensors to report back their positions in the closest beacons. Okay, so consider this. Consider 218. Closest beacon to it is at, okay. This isn't necessarily a comprehensive match of all beacons in the area, though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that close or closer to the beacon. There could still be beacons that just happen to be the closest beacon to any sensor. Consider whatever. Okay. Sensors close beacon at 218, so you know there are no beacons that close or closer in any position where none of the detected beacons are producing a distress signal, so you'll need to work out where the distress beacon is by working out where it isn't. For now, keep things simple by counting the positions where the beacon cannot possibly be along just a single row. So suppose you have an arrangement of beacons and sensors, like in the above example, just in the row where y equals 10, you'd like to count the number of positions a beacon cannot possibly exist. The coverage of all sensors near that row look like this. In the example, in a row where y10, there are 26 beacons where it cannot be present. Consult the report and sensors you deploy. In a row with this, how many can there not be a beacon? Okay, so let's take this input. I'm so confused actually. Okay, so in a row, Okay, this is the thing. But this says row y equals 10. And this is y equals 200,000. Okay. It's kind of curious. But, oh, this is going to be kind of annoying, actually. So, test dot part 1, let's say 10, and then this is gonna have to be, because everything that I do here is lambdas, so we're gonna just add that in. This will be fine. So it's this, but it's like, oh crap, I'm actually editing the wrong one. That's annoying. Ha. Okay. So let's do this. Okay, so we're gonna pass in the y thing. I'm trying to think about how to do this. We can just naively put it into a grid like we did last night is probably like fine. Today.part 1. And let's just copy this thing, and then there's 26 where it cannot be present. So we know the answer is 26. Oop. Okay, so in this example, it's like we have some sensors, we have a beacon. So this kind of tells us, like, we can use this to mark out sections where it's like not, right? So what if we have like a, I don't know. Let's see. This is kind of interesting because it's like, oh, this is the closest one, so we know we have these kind of like diagonally kind of sections. But I do kind of like it to just be as like a big grid. So, okay. Let us sensor. So lines dot, we'll do the normal thing, val things. I don't really care what they're called. And these are lines dot split. Hey, what's going on? I don't know why chat doesn't show me. Cool. So for each line, we're just going to map it out, and we are going to it dot remove prefix. We should just get rid of all this, but I'm going to parse it out anyways. Dot remove this is fine. And then now what I can do is split on just split on space. It's fine. Okay. And then now what I want to do is I'm going to map this, and we're going to get the first coordinate. So val sensor equals, this should be the first one, and then we're going to remove prefix x equals. And then the second part will be nope, and dot remove. Actually, this is kind of a pain. I have a better way of doing this. Don't do this. So we can do this, and then we can do this all ints magic that I made. It's it is a, oops, sorry, hold on a sec. Talk once I can type. It is a regular expression that pulls out all the integers. So this should just give me like, it should work for positive and negative. So it dot 1. Oh, this has to be xy. And I will print these out to make sure that, since that this is always our demise, right? Okay, and then just here, print line things. Actually, dot for each print line. Good. Okay, let's see that. Hey, what's going on? Okay, cool. So that has the, oh yeah, the first one's here. So it does pick up the -2, 15, everything's good here. Okay, so all of the beacons here are positive. I don't actually know that that's the case, so we'll just, we're gonna do min x val, min x equals things dot min, actually, I think it's min of, yeah. And then we're gonna get the first, and we're gonna do the minimum x, and we'll do minimum y, just in case we need to like offset stuff. Okay. Because like this one, it actually is x equals 2, and then it's telling me the closest one is at y is 2. So, okay. And then it actually just wants me to do like that one line, but I don't actually think it's that easy. So I'm just going to do the whole thing. Grid equals min x. So we'll do immutable list, Boolean. Oop, I don't actually need that. And we're just gonna make it just like ridiculously big, I think. Is this gonna hurt us? I don't know. I mean, we don't need it for this, right? So maybe I'll just do, though the other one we kind of did, like the first part we actually kind of do need it, but that's okay. Oop. Okay, so let's see. We're gonna check, it says in a row, how many positions cannot contain a beacon? So let's just say every place can contain a beacon, and then what we're going to do is we're going to go through for sensors, so for sensors, and then what I want to do is varlock equals. So what do I want to do? I have a spot, and I want to go through all of the options for how to, I want to step through all of the locations that cannot be picked. So, okay, val lock equals s dot first. Okay, and then how am I going to get these ranges? So, like for this one, it's like -2, 15. But really that's like a distance of 17, right? That you can allocate kind of in any direction. Because I think it's closest by Manhattan distance, right? So it's like, where to say? It says closest. It says consider sensor. The closest beacon is 215 for the sensor. Like, I'm pretty sure it's saying, like, yeah, like it's the closest by Manhattan, as measured by Manhattan distance. Yeah. So what this is saying is actually like val total equals it's saying that like nothing can even be like kind of close. Sorry. X and Y. So what we want to do is we kind of want to like walk through. We want to walk through where I is. So like let's just take x, right? So x in, and then we actually want to do like negative total to total, okay? So that's going to say like if it's 17, you can only go that wide, right? And then for y, we want to be in, and we want, this needs to be negative total minus x. So if the total is like 16, then we can go up or down 1, right? We want to do that to positive total minus x, because that'll give us all those Manhattan distances. And then we're going to say grid equals false, you know? Oh, grid y x equals false. Okay, and then this is going to return, I think it said how many can it not be in, right? Like where, how many positions cannot contain a beacon. So we can just do grid grid I, that's the input, dot count, it equals false. Yeah, shut up, I'm sure. Whoa, wait, this is wrong, because we didn't add in this location, you know? So val pose equals voc plus, actually just add them in here, right? Lock.y plus lock.x plus, okay. Creating this might take a while. Okay, don't do that. Oh geez, okay. I'm probably gonna have to come up with a better. I didn't actually even use this, by the way. What is going on here? Oh god, come on. I think this is just taking a long time to allocate. Done grid. But I could be wrong, so I'm gonna just sensors. Alright, cool. Get that. Hey, what's going on, everyone? Yeah, okay, this is taking a long time to make. It shouldn't actually take that long. It's let's see. Maybe if I just set these, let's just reverse this, dude. Like, what if I just take this out? It's just gonna be a Boolean array for whatever the default is, right? Which I think would be false, so maybe this will be quicker to... Is this not? And then we'll just set it's true. We'll just say count it. Okay, let's make these super small. I don't even need them to be that big. But 100,000 doesn't seem that big to me. So, however we're keeping track of this is not going to work, right? Done grid int x minus 16. Oh, it doesn't like that. Doesn't like that at all. Okay, this isn't going to work anyways. We need to do this more smart. So, oh gosh, okay. I mean, we could try it. We can... No, it's not actually going to work because the whole thing's too big. This is like 200,000. So what we need to do is we need to be putting these in a map. So instead of this, we're going to do grid equals mutable map of. How big is the actual input? It's not actually that big. It's not that big. Okay. So let's just okay, this is wild then. We don't need to do this. What do we want to do? Get rid of this. We don't need this. That's the dumb way. What we want to know is we want to know how many of these don't work for 200,000, or for 10 rather. So instead of doing this is actually fine. We just want to count, let's just keep a set. Let's just do val set illegal equals mutable set. Oh, I should have done this before. Of coordinates, and then we'll just add these in, right? Add coordinate dot xy. Oh, we don't want that, but that's okay. I don't know how this is going to generalize though. Like this seems hard to generalize actually, but oh gosh, what am I doing? Y plus y. Okay, like that. And then what we want to do is we want to dot count it dot y equals I. This should be a significantly smaller. Shoot, what the heck's the result? Here. Oh, here. Print cut 85. What? Really? Okay. Am I just not understanding the question? So 218, the sensor, and the closest beacon is at -2 here. No. Oh, x equals 2, y equals 18. And the closest beacon. Oh, I'm an idiot. These are not, the closest beacon's there. This is not the diff. I thought this was the Manhattan distance. Okay. Yeah, that's not it. This is not that bad though. So instead of this, what we actually just have to do is, so I thought this was the distance, but it's not. So what we need to do is we need to do, this is no problem because we can do this, right? This is what we want. So we just want to know the distance between the beacon and the sensor. I switched those there, but you know what I mean? Oh, no. Okay. Let's just do some printing, because that's what we do. So we need... Actually, just want to print S, yeah. Okay. This should make it pretty evident. So 2 and -2, that seems good. That seems good. What's the issue? Right? Yeah. Total this seems fine. Okay, so let's see. This. Yeah, so it could be this. What are the dots? Oh man. Okay. What am I missing here? So let's oh, but it's a minus. Hold on a sec, yeah. I think it's -1, right? Because closest beacon is this. You know there's no beacons. It says that closer. Okay, what number did I get? Expected 26, but got 33. Is there some beacons on 10 that I have to subtract? No. Hold on a sec. Oh, I don't think this is the right. Or it is. Is it this? 1, 2, 3, 4. And then. Okay, so this one seems interesting. This seems like a good case, right? So 1, 2, 1, 2. Okay, so let me check. Let's just print out these. Let's just do this. So line I, and then line I dot oop for each. Oop. Okay, let's do that. And okay, so -5, 10. Is that? Okay. Am I just counting too far off the side? Is that all that's going on here? It's like 4, 3, 2, -1, 1. Yeah, what am I missing, guys? Let's see. In this example above, one, two, 4. Oh, no, I don't get it. Okay, I need to figure out who's putting in this one. So let's just do, I think that's where the issue is coming in though, right? Yeah, I think that's where the issue is. If let's just do this. Val new x equals this. Val new y equals walk y plus y. New x, new y, and then I guess I can just frickin' put a breakpoint. This is a jank, dude. So you never want to be doing this, right? New x equals -5. Anytime you're putting in breakpoints, dude, it's like you've lost the game. New x equals -5. Done. Yeah, I'm trying to figure out why this is getting put in, right? So new x, nope, and new y equals 10. Okay, so this is the right one, right? Negative 5, 10, and this is 2. So 2, 18. Okay. Yeah, this is that spot. Am I doing this just straight up wrong? So it's not this one though. Oh, there's something going on here though. That's messed up, right? So this is talking about this, I think, right? Oh wait, wait, what the heck? Did I mix these up? It says, oh, 218, negative 215. Okay. But how am I getting to this, dude? No. Something's messed up. Lock first, minus. It says x. Oh no, dude. Okay, so the sensor's here though at 2. Yeah, something's messed up. Because I get 218 is the sensor. It's this one location, right? And then the total is just 7. And so so if x is negative 7, oh no, oh no. Oh, crud, that screwed me, dude. Yeah, oh man. So yeah, I was making it way too big. I was making the search area way too big. Oh, now I got a list, dude. Okay, this should be it though. Right? No. Okay, but I think it's because there is one beacon there. Okay. So minus, and then what I should have to do is beacons I equals. Okay, here we go. Count, and then it second dot y equals I, and then we gotta. It's only a little bit confusing. I should have just what? No. What are you talking about? How'd I get more? What the hell? Oh, that's still not what I want. Ah! Okay, I did it again, guys. Oh, wait, no, I didn't. Closest beacon is at. Oh, these are all the same closest beacon? Oh, you gotta be kidding me. Okay, Okay. What the heck? Okay. That's actually, like, kind of nice, but, okay. Is this it? There's a bunch of them that have the same. Wait, what did I do now? Second. Oh, okay. I'm losing it, right? Okay. There we go. Oh my gosh. Okay. So what happened there is a bunch of these mapped to the same, like, closest beacon, right? So, okay, where's the frickin' output, though? Wait, what? I literally don't understand. Wait, it's still running? Are you serious? Hold on a sec. Okay, well, this approach is not gonna work. Okay. Okay, okay. Okay, I learned my lesson, dude. Just piss off. If illegal dot y equals I, right? Or new if new y. I'm gonna change this. I'm just gonna say not here. Okay, this is also stupid because we only care about the one spot, and we know what the total is. I'll still kind of do this a stupid way, but I'm just gonna say if lock.y. What am I gonna do? I need to know if the distance between lock.y and I is less than or equal to total. I'll say if the distance is greater than total, then I can just continue. We actually don't need to do all the rest of this. This is just a lot of garbage that we don't need to do. So here we can actually tell how close they are, right? So this distance actually is exactly what we're looking for. Because we only care about the ones where it's big enough. So instead of looping through total, we can limit x. Oh, let's see. So if we need y to be at least, I'm just gonna let this run. It actually literally has not added. It has not added a single entry here. So this has got to be just like quite large. Right? Yeah. Closest beacon, like, okay. I should have looked at this input before I started. This is crazy. Okay, so what we know here is this is, I'll say ds to I is this. So it's the distance from this sensor. Let's call sensor lock. Diff to beacon. Okay, so this tells us how far we can reach, and then this says how far are we from the sensor to I. So this is the amount of, this is where our Y has to be. Our Y actually has to be in this space. So let's just do this the other way, right? So you can actually switch these, and then we can make it so that we actually want to know which direction it is from the sensor too. So absolute value doesn't help us. So if our beacon is at 20 and this is at 10, then we know that, okay, so this actually has to be backwards. So if we're looking for 10 and the beacon's at 20, then we want this to be -10 or less, right? Does that make sense? So if sensor at 20 and care about I equals 10, I have it as I, but it's Y obviously. Only check when dy. Yeah, so this is right. Only check when dy is less than 10 or less than -10, right? We need to go back up. Okay, so I like this. So then this goes from negative total, because that'll be the one right in the middle, right? So we can count a bunch there, that's fine. And then this is gonna go to ds to I. Okay, and then this is y. Okay, so this cuts down the search space a lot. It's still very big, but this should be like kind of doable, I think. Oh yeah, this is just going up and up and up. Okay, cool. Unless, did I stop this? Okay, yeah. Okay, does this still get our 26? It does. Okay, and then what do we care about? So we don't actually need to iterate through all of these either, because what that's going to do is going to say at this height we can do this many. So we actually only care about it when it's this. I don't know why I just did this. So can I do this and say when y is this? Huh. Okay, what? Negative total, this absolute value. And then this is okay, let me run this. It likes this, it likes this. Okay, what am I doing wrong, guys? So this is the distance that I have to go. And I add them all in. I'll let this run for a little bit. Does this make sense? I'm like racking my brain here, right? Because it makes sense for this case, right? Or maybe it doesn't make sense, right? Because if we fix y to be that, then we could walk through all the Manhattan distances across, right? Oh, but I guess we need to check. We need to check that if we can get there, right? So if if abs of ds to I is greater than total, then we need to bail. I think that's the thing. I think that's the thing. Okay, let's do this. Oh yeah, here we go. This is a lot. What crap. There's a question that's like, do I need to be generating all these? I'll let this go for a bit. Nope, came up with a number, so. I didn't need them as a coordinate. Okay, that worked. Nice. Your handheld device indicates that a distress signal is coming from a nearby beacon. The distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates no lower than 0 and no larger than 400,000. Okay. To isolate this distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by 400,000, or by 4 million, by 4 million, and then adding its Y coordinate. In the example above, the search space is smaller. Instead, the X and Y coordinate can the X and Y coordinates can each be at most 20. With the reduced search area, there is only a single position that could have... yeah, I'm not understanding this, but I'll have to read again. Find the only possible position for the distress beacon. What is its tuning frequency? Okay, so it says... Okay, so it says the distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates no lower than 0 and no higher than 4 million. To isolate the distress beacon's signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by 4 million and then adding its Y coordinate. Okay, so this is just like a unique number. That's fine, because Y can't be any higher than 4 million, so it's like kind of concatenating them. Right? In the example above, the search space is smaller. Instead, the X and Y can each be at most 20. With this reduced search area, there's only a single position that it's this. Okay. This is like... this is... Okay. So we saw earlier that when I tried to put things in the 4 million, that it really didn't like it. So one thing I'm thinking about is Manhattan distances are like a box, right? They're like a thing like this. And what we're kind of trying to do is we're trying to find the one... Like, can we just do this by scanning? Can we just scan? So instead of trying to track all of the things, right? What if we can just look to see if they're like close enough, right? Okay, so let's probably gonna keep some of this, but okay, we have these sensors. I really don't like this because it's just too... It takes a very long time. So what I think I want to do is dimension, okay, and then I'm just gonna do like 4x in 0 dimension for y in 0 dimension. So we're just going to go through them. And I'm going to do the same thing here, right? So I'm going to say today test dot part 2, and this is at most 20, right? And we expect what's the expected result. Okay. So if something, I'm going to say if true, we're going to return x times, is it still x times 400 million or whatever? Yeah, it is. So x times 4, 3, okay. Plus y times, okay. So, like, why don't I just check, like, I'm just say is possible xy. Okay. And yeah, not implemented. We're just gonna say false. We'll figure that out in a second, and then throw runtime solution not found. Okay. And so in order to figure this out, what we need to do is we're actually going to do one more thing. So we're going to do sensor dist. And so I just want to map dot map. Okay. And we're going to do it dot first. That's fine. To, and then the second one, we just want it to be a number, right? We want to know how far away it is. And then what we can do is we can go through all these and calculate the distance from where we are to each coordinate and see if it's under the distance, and that would be true, right? And there's not actually that many sensors, so this is going to be like 4 million times 4 million isn't that many. I think it's okay. So it dot first minus it dot second, this will give us the distance, right? Let's actually do this. Do diff equals this val, and then this is just going to map to what we did before, right? Diff dot x plus diff dot abs diff dot y. Okay, and then what we're going to do here is we're going to say, so the last one is return false. Wait, last one is return true, right? And so then what we say is say for ds in what I call this thing? Dang it, sensor distance. Okay, SD. Okay, and then we're going to start out by making position equals chord dot xy xy like this. Okay, and then I'm going to say var diff equals pose dot minus SD first, and then we'll say if diff, we're going to do the same calculation, right? If diff dot x plus diff dot y. I should just make, there'll be more utilities tomorrow, right? So this is the distance between those. And we'll say if this is greater than SD dot, or we'll say if this is less than or equal to SD dot second, then we're going to return false. Otherwise return true. So this is saying if we're far enough away that, you know, it's not within this sensing range, then it's possible that it's here. And if it's possible it's there for all of them, then we'll return that thing. So see if this works for this. But what the heck? What number is this? 10 million. Found it. X, Y. Okay, well, it did return something, so that's good. Found it 1411. Is that right? No. Only a single. Okay. Coordinates. Oh, multiplying. Wait, what'd I do? Oh. Why'd I multiply them both by that? Oh my gosh, this might actually work. I mean, we'll see. Right? So I'll run it, and then this is actually this, right? Really? Oh, no. I was like, that's not, it's not that it's not possible, but it's unlikely that it would execute that fast. That's what I'll say. I have no idea how long this is gonna take. So what I probably should do is like, I'm just gonna start that over. All right. Oh my gosh, this is gonna take too long, I think. Okay. So yeah, too long to say the least. What do I do here? This is tricky. So can we shortcut these at all? I think one way to do this be I'm trying to think if there's some way for us to like know that it's faster. Because obviously this is, or know that it's that it's so how can I do this check quickly? Right, because let me just verify something. So if this is just like, if this is nothing, I'm trying to see if it's even reasonable to like loop through all these, and if I could just do this check quickly, or if I need to do something else. This is fine. That's kind of slow, but it still isn't that bad. I mean, if it was this, I would just wait the time. But I don't even know that that's possible. So what can I do? aside from like sharding this, right? I mean, this is printing so fast that it's like, I mean, we're already through 30,000, but if x mod 1,000 equals 0, like, does this make this go faster or not really? No, I mean, this would still be like 400 seconds or something, even if we knew immediately. Which sucks, because like this check is relatively quick, I think. Right, like there's only 26 elements here. And we know let's just do this and let it just go for a bit, but it just seems like it takes a while, right? Is this lazily evaluated? I don't think it is, but we can just to-list this to make sure. So what I'm thinking here is that we need a way to like actually be able to do this like faster, right? There's only one element in here that we can do. Like in part, I mean, we can go back to part 1. This did take a while though. So we went through like this was just for one line, right? And it said I wonder if we can collect ranges and then like merge them. So like going back to this one, right? So like I know like I'm only looking for one line. We don't need any of this stuff, right? So let's actually just go back to part 1 and see if we can like do it even smarter, I guess. So we know exactly how many up we want to go, right? We know when to skip this sensor. And then we can actually use the sensor dist now, because that's what like that's what this does. Excuse me. I guess I'll leave this, but it does seem, well, I don't know. Let's just see if we can do it. So, oh, but this kind of loses where the beacon is. Do we care? We don't really care, right? Or we'll care later. We'll care when we have to check to see. But like this diff to beacon, this total, all of this stuff is already done, right? So the total is s dot second. And then, so I'll just do that actually. Val total equals s dot second. Oh man, we're just over an hour. Okay. So this we don't actually need to do any for loop here, right? We just need to do val y equals ds2i. Okay, so that's good. And then for y, or for x, like we were looping through and adding these together, which is cool, but we don't actually need to do that. Oh my gosh, this is actually insane. There's a problem that we did super early on that dealt with the same thing. Okay, that's cool. So, sorry, I'll explain this in a sec. So we actually already have the range, right? This is the range that we know things are going to be in. So like we're just going to keep a list of these ranges, okay? So we're going to say not here is like this int range, right? And the int range is this. It is this range that things are not in, right? And we've already done this problem before too. So we don't need to do this because we know all of these are in there. Oh, this is nuts, dude. Sorry, I'm like so stoked. I'll be stoked if I can get this working, right? Okay, so we have this. We know they're not there. And then this filter is not going to do anything, right? But because I am a little bit lazy, I just want to confirm that this is what I think it is. So I'm going to say flat map, and then for each range, these are all the x's, right? So I'm going to map all of these to coordinate of it, coordinate x, y, it, and I. And then that's actually what this is, right? And then I'm gonna do dot distinct. And I'm just making sure that we get the same answer. Okay. Oh no. Okay, hold on a sec. Isn't this what I had before? Oh, okay. I did this a little too quickly. Oop. Okay. Does that still work? I don't know. I don't care about that though. Don't care about this. Okay, this still works. So what I wanted to do here is instead of doing all this, I just want to do y is exactly this. So I'm pretty sure this is true. I don't think we need this, right? Because it's not doing anything. Right? Okay. Cool. Why is it printing out all this random stuff? Okay. And then I'm going to say this is not here range, and this is just going to be an int range. Okay. So instead of doing this, I can just do add this range, a total minus. Oh yeah, that's not what I did. That is not what I did before, right? Not here. Range equals val line I. Not here. Range dot flat map. It dot map. So we need to map each of them to an XY coordinate, right? And then that we're gonna do distinct, and then Okay, this should all still work. I didn't subtract out this before. Does this still work? No. What is going on? So... I guess just print out which ones are there, right? Yeah, this is nuts, because it seems the same to me, so... As expected, but got 12. Yeah, so these are the X's, and then we already had the Y's. Oh, that's why. There you go, there you go. Because this isn't actually what I need. This, because the spot is not the same. Okay, so so I actually need to add this, right? So plus this. I need to offset it. Oh my gosh. Okay, this is a lot. But wait, what the heck? Why'd I? Okay. Yeah, I need to offset it by the X, right? Because these are X ranges, but they're still like relative to the sensor. Okay, there we go. Nope, that's a lot more. Oh god. Okay, what am I doing here? So... I got a lot more. Let's try to just do this to see, like... I'm pretty sure I know what we have to be doing here, but I don't... Okay. I have like an off by 1 error or something, right? So... oh, wait, it's this. Aww. Okay, that is a disaster of a frickin'. Okay, so this is what it is. This is like, this is like the X range, val X. I'm just gonna extract this. Or I'm gonna say dx. I'm gonna say negative dx. And then this is also dx. Okay, okay. Now here's where the stuff comes in. So this is distinct. This seems fine. This should be a lot faster for this one, right? I mean, I still put them out to coordinates here, but I don't need to do that because they're all this. So I can actually just like, I can just do this. Okay, that was pretty snappy. I don't know if it's snappy enough to work in the other part, but let's see. So the other thing that comes into play here, I think, is if we can just not do this. And there's one that's like, we already did a problem where it was talking about, let's do fun part 2.2 dimension int. Actually, I can just replace that other thing. So no, okay. So what I was thinking could do is I could take this loop and I could replace it with so instead of doing this for all x and y, right? Now we know how to do it for y just like quickly. So so what if just for y in, it's like we can open this up and say, we can say any open for y. Let's just do that first. I don't know what this will be. Just say 1. It's like to do find x. Okay, so right fun any open y int, and we're just going to utilize this thing that we like literally just had, right? So okay, I'm gonna use I again actually, because like that's what I had, right? So here I just want to know if these, so the key here is going to be this thing. This is too slow, we're gonna have to make it faster, and we did that in a previous example, right? So I'm gonna say this is not equal to 4 million or whatever. I'll just pass in dimension. Okay. Nope, this doesn't. Okay. Does this work? No value pass for dimension right here. Frickin' work. Okay, that was the first part. That's not what I needed. Okay, I think we're kind of onto it though. It doesn't seem like it, but I think we're getting like pretty close here. Okay, so begot for, oh, that's not. Found it 0. 0 even option? I don't think so, dude. I'm just gonna do this. Print line count. There may be an off by 1 kind of thing going on here, so. That, oh nice, it knows it. Count that, go. Count 35, but that, okay. that's... I guess what I should be doing here, though, is dot filter it is less than 0, or it is in 0 dimension. Okay. Again, we can't do this later, but 21, what the crap? Oh, because we're counting 0. Is that also true for this? This is no lower and no larger than. Yeah. So dimension +1. Okay. Found it 3. That's wrong. Dang it. This is bad. This doesn't work. It should work though. Yeah, man, it should work. Probably don't actually want to do this, right? Does the beacons already count itself here? Is there a beacon in 3? There is. So we don't want to subtract out the beacons because there's not a beacon in the beacon spot, if any of that makes sense. Found it 11. Okay, that's good. So what I actually want to do here is I'm going to return a pair of boolean to int, and what I need to do is so what I'm going to say is val found is this, and then I'm going to say if found now it's like just go check to see like var num equals 0, and then I'm gonna say 0 to dimension dot first, and then I'm gonna say not here range dot none. So first x where none of it dot contains x, or none of them are in x. That sounds good, right? So I actually think that this is the line that's just dead. We need to fix that, and we should be able to fix it in a sec. Let's see. So any open, okay, and then this has to go like val open x. So we're unpacking our thing. And so then if this is open, we should put x in here, found it, x, y, boom. Okay, 1411, okay. Let's see now how this runs on this. If y is in, let's see, 100? I don't know. How slow is this thing gonna run? Oh, we need to start it up. We also should get rid of these lines that we don't need anymore. So this algorithm will work. It's just gonna be Oh my god. Heinously slow. Okay. Wait, but I knew that, right? Because I'm like, this thing is slow. So what we're going to have here is we're going to have 26 rows, right? And we need to be able to... We're going to need to be able to merge these. And we like had one early on, right? Where we were like talking about... we wanted to know if like int range, like if they overlapped, right? So iterable int to range. We just need to be able to join some ranges, so I'm kind of looking around. I'm letting this run just a little bit, but each one of these is one row, so it's way too slow. like just hilariously slow. But I think it's like all start. I think I can do this. I don't know. Val start equals system dot current time. I just am curious how bad this is, and if we fix this, if this whole thing will. Took n minus. I'm glad to have this music though. I'm like vibing on this. It's pretty good. Yeah, so this is slower. This is slower than whatever we had before, but okay. This is the whole thing. The entire thing is taking this. So if we can just fix this thing, let's actually see. So if instead we just assume this is this, so just comment all this out. Let's just pretend that we have some magic and we like val count this. This is always good to just kind of benchmark, like, can I loop through 4 million things? Solution. Oh, that's because that's the test thing. I don't want that. No, I need to know if it can get through this thing. Yeah. Yeah. Okay. We just have to be able to do this quickly. And this is totally doable. So I'm just gonna go and kind of look real quick. I don't remember which day it was. Is this? Overlaps. So we just want to merge ranges, right? So we want to know like yeah. So okay, we can't do this. Not start here. What we want to be able to do is for how do we efficiently merge ranges? So we should not here range. Okay, let's sort them first by like it dot first, right? So we're just gonna sort them by yeah, dot to list. Actually, this is good. And then so this is just going to give us them by the first in order. right? And so we can kind of scale them up by that. And so then what can we do here? We can var big range. Oh yeah, dude, this is it. This is it. Take this and range list dot to list. Okay, and then I'm gonna get the first one. So range list 0. Oh, we are getting close. And then R in range list drop. We just want to get rid of the first one because we don't want to count it twice. And then what we're going to do is we're going to say if we had this. Okay. Say, just want to check to see if they overlap, right? Actually, we don't even need to check that. What we want to do is we want to say if r dot start. So since they're ordered already, we need to know whether the start is less than the end, right? And we know that the start is at least equal to the start of the first one since they're ordered that way. So if this is the case, merge them. Do we even need to merge them? We don't. We really just need to keep track of the last thing. So this is what I'm going to do. Say var start equals range list this dot start and end is end. Okay. And then if this is before the n, then we can expand it, right? Oh, is there no n? Dot. Oh, for and inclusive, what the heck? Yeah, last. That's fine. Okay. So then we can just say n equals r dot. And inclusive. Okay. Else, then we know that the number that we're looking for, you can just say found, so we can grab all these, right? So actually here, we can return true to r dot, or we can do n plus 1, right? Because there's only one spot that it could possibly be. Otherwise here, we don't need any of this. And we can just do start is less than or equal to n plus 1, something like that actually. Return false -1, something like that. Okay, so this works because and here we just want to say if start actually, well, this is not gonna, it's not gonna be the case, but we can just do the check anyways. If start is greater than 0, then we return true to 0. They're not gonna do it like that though, because it's kind of a weird, it's like a degenerate case a little bit. Okay, does this work? Let's get this working on the test input and then let's roll. So got found 11, 0? What the heck? Okay, we know that this is bogus, so we'll just figure out. I just have a bug in the code then. So this is saying that x equals 11. So I mean, we can just debug this real quick. Okay, so it says it's going through the range list. That's cool. And ooh, interesting. Oh, okay, so this is where I screwed up though, right? Because the end here, so I moved it forward. So so if the start is, so this is actually where I can just grab this thing. I'm like, let me just say val big range equals range list. I'm gonna go back to this because I want to have I just want to be able to check for this. This is what just happened to me. So okay, what this is saying is if big range dot start. Okay, and this is a variable because we're gonna update it, and then we'll say if big range dot contains r continue. Okay, and then if I mean, I already used the other one, so why not just use this one too? What the hell? And then we can do if they overlap. So if big range dot overlaps r, then big range equals min of big range dot start r dot start to max of big range dot last r dot. All right, that should be it. Do it. Oh, it doesn't like this. Oh, it doesn't like this because what? I just need to import it? Are you serious? Can't believe these don't get imported automatically. I mean, it just seems like a very standard like thing to me. So, oh damn it! Wait, am I hitting the same thing? What the hell? R. So let's see. Great. Wait, I equals 11. No, that's good. And then, oh no, this is just, I'm just returning something bogus. Dot. Oop. Yeah, that's fine. It's not what I meant to type, but it doesn't matter. Got it. All right. Here we go. And we'll just kick back and wait. It should just be a second, actually. Got it. All right. What? Wait, what? What? Are you serious? Let's just like x, y, and then because we have our checker, right? So, should be this. Did I? Okay, so this is what it says I put in. It says right there, it's possible, true. What did I do wrong? Did I read the question wrong? What the heck? Okay. What if I just, what if I... Dude, I felt so good about that. Oh my gosh, what the hell? 4 million. Okay, that's what I'm gonna do. This is like cruising through them. So I'm just gonna get rid of that. Wait, where am I printing this? Serious? Oh wait, this is y. Y equals. Okay. Someone's chatting me up. I'm like, oh. Yeah. Yeah. It's so weird. This actually is returning a bunch of stuff. Let's just let's do this. Answer. Okay, I don't worry about that. Oh man, what the hell, dude? Okay. It literally has found one answer. It thinks this is right. Like, yes, I can. Well. let's just do this. Instead of doing that, I'm gonna I'm going to, this is annoying now. It says right there. It says is possible true. Am I just computing? Like I literally checked to see if it works and it says it does work. I don't know, dude. Anyone have any suggestions? Yeah, let's see. No lower than and no larger than. That's fine. Tuning frequency. It's this and then XY. I mean, I got the test. I got the test one correctly. So. Let's just keep doing this. Let's do list ranges dot add. We'll add the big range and then we'll just say big range equals R, and so this will kind of accumulate stuff, and then I'll say if big range is equal to 0 to dimension, and we can return this, otherwise do some other stuff down here, right? So otherwise I'm gonna here what I'm gonna do is I'm just gonna print the, oh, that's not what I want. I want big range. Oh yeah, no, I do want that. I'm gonna say that. Okay. Big range equals yeah, this is frustrating. So I'm assuming that if I get to this point that, like, I mean, if I wanted to test the same thing, it'd be like val x equals list ranges. And I think there'll just be 2 items in here, but maybe I'm wrong. And then val y equals I, right? I'm just gonna pass false here anyways, just to see if anything else gets printed out, but what is going on? Oh, it's still running this. But this covers... Okay, so this is not actually what I want. I want to say big range dot contains, oh. Is this not the same one that I literally got before? Is possible? Am I returning the wrong thing? Like, why I don't think so, dude. I think I literally just might be... Is this number, like, listed as a sensor or something? Am I just computing the answer wrong? Like, there's no way that I can compute the answer. I mean, no way. Ha ha ha. Oh, okay. So, oh, wait. This is actually kind of weird. Why am I getting, like, a bunch of different answers for the test one? Right, so it thinks that it's, like, 14. Because this is true. Okay, that's good. Why does it come up with these, like, bogus answers, though? Oh, but this one's in there. So... Oh, okay. Okay. That's because this isn't quite right, actually. But it only kind of manifests in this test, right? So if it overlaps, then you can do this. But you want to check if they abut too, right? So this could be or big range dot last plus 1 equals r dot first. Then we can do the same thing. Right, found it. Yeah, okay, sorry. I'm like looking at this and I'm like, what? This is exactly the case, right? So actually here I just want to do list ranges dot add big range and then print them all and then get the first one so this should show that, yeah, it's like there's just one in the middle. It's literally that one answer. How is it possible that I'm getting this wrong? I mean, it's the same answer that I got before, though. Right? You know what? I'm an idiot. Oh my... Oh, I'm so effing mad right now, actually. I am so stupid. This is an int overflow. I cannot believe this. Long. Yeah, this is an int overflow. Oh my. That's so frustrating. Oh man. Oh. Okay. Um, this one's a really cool problem, actually. That's just really annoying that we had the right answer for 45 minutes, probably, and just returning the wrong type. So it's so funny. Earlier on in the series, I was like really paranoid about int overflows. Basically, when the number gets too big, right? Instead of being able to hold it in 32 bits, you need more. And if you don't have enough, it just wraps around, and that's what I got bit by here. So we had the right answer. Let's just talk about part 2 real quick because it's interesting. So the search space is now very big, and so what we ended up doing is kind of going back to part 1, right? So in part 1, we were just like filling out this space and figuring out like where can these things not be. And there's so many spots that it can't be, right? In the end, we're searching a space that's 4 million by 4 million, which is quite a bit. I mean, each row, if you just have 1 byte, 4 million is a megabyte. So 4 million megabytes is a terabyte or something? That seems like too much. I don't know. Anyway, don't do it. So what we did instead is we said, okay, cool, for this row, how do we know like what's not allowed to be in the row, like where it can't be? And so you can look at each sensor and say, okay, the sensor's this far away, like can the sensor even reach that, right? Like based on what it knows about. So that's what this ds to I is, like distance from sensor to I. I mix up I and Y here because I use Y in other spots. But then from that, what you can do is we can compute a range on the x coordinate where like that sensor says, hey, this cannot, the thing that we're looking for can't be here. And so we collect this group of ints. And then here we just do the cheap thing. We're like, cool, just expand these int ranges to a bunch of numbers and we'll just count them all up and we'll get the answer. But it is horrendously slow. And so then what we can end up doing is using the solution, I guess it's from day 4, right? So they had us do these contains and overlaps. Remember, it was elves like working in the camp or something like that, right? And so instead of trying to count them up, what we could do is just see, we can try to combine the ranges, right? And so that's what we do here. We just go through all the ranges that we have once we've computed them already. So this computes all the ranges, and then we merge all the ranges together here, and then we just return the, if the range doesn't cover from 0 to the full dimension, then we know that that's the x and this is the correct y, and that runs pretty fast. And then just in the end, just returning along to make sure that when we multiply these two things together, they're big enough. What's actually frustrating is I should have noticed from these two that that's what was going on. But in the end, we got it. It was kind of fun. Kind of tricky. Like I said, spent, 45 minutes just not realizing we had an int overflow. And we still didn't do that bad. Yeah, I feel like we could have picked up probably 1,500 points, right? But still a pretty cool question, so glad to have it done. Happy to go to sleep since it is very late now. So catch you for day 16 tomorrow. Till then, take it easy. Yep.